Hi, everyone. Welcome to our program today. Thank you for being here. I am Sophia Porter. I am the Fire Smart Landscaping Science Coordinator out of the Cooperative Extension in Marin County. So today our program will highlight a brief overview of some of the basic principles of Fire Smart Landscaping. I believe all of you were sent a page of resources to review to kind of get yourself up to speed. And then our speakers will also discuss some new information and also what's on the horizon and policies and things coming up. Just want to give a shout out to the people that helped put this program together today. Like I said, it's a tri-county, so Napa, Marin, Sonoma. So welcome all of you. Like I said, my name is Sophia Porter. I also want to give a shout out to Mimi Enright. She's the program manager, community food systems at UC Master Gardeners program in Sonoma County. Yvonne Rasmussen, also within UC Master Gardener Volunteer Coordinator up in Napa. And then we also have Stephen Swain, one of our speakers, who is also one of our speakers, the Environmental Horticulture Advisor from Marin, Sonoma, and Tori Norville, our UC Fire Advisor from Napa, Sonoma, and Marin. So this is today's program. We're going to kick it off with Stephen Swain, again, the Cooperative Extension Environmental Horticulture Advisor for Marin and Sonoma counties, with a brief review of Fire Smart Landscaping and the fundamentals. And so Stephen's work focuses on landscape issues in North Bay, where he conducts applied research with industry and public agencies, personnel, and integrated pest management, plant pathology, and resource conservation. So Stephen worked as a consultant in the landscape industry, as a board-certified arborist in Santa Cruz for almost a decade in the 90s before attending the graduate school at UC Davis. He continued with a postgraduate research with Seven Oak Death at Berkeley. Then we have Tori Norville. She is going to be covering insights of fire behavior and updates on defensible space in Zone 0 near structures. So Tori is the fire advisor for Sonoma, Napa, and Marin County. She spent 9 years at CAL FIRE as a forester in Mendocino County before becoming the UC Cooperative Extension Fire Advisor. She teaches fire ecology and the importance of structure hardening and defensible space, land management techniques for pre and post fire resiliency, and how fire can be used as a tool. She hopes over time people will grow respect for fire rather than fear it. Then we have Luca Carmignani. He is the assistant fire advisor in the South Coast, an extension center there in Irvine. He collaborates with university agencies and organizations to provide science-based solutions for wildfire preparedness and create fire resilient communities across the Southern California. His research focuses on fire risks associated with wildland-urban interface, vegetation, and structures. And I'm going to go down to Steve Quarles. He is a UC Cooperative Extension Advisor Emeritus. He's going to be covering mulches and mulch study that's underway in Marin County. Steve serves 26 years with the UC and 8 years as chief scientist for wildfire and durability with the Institute for Business and Home Safety. His research and outreach focuses on wildfire protection for residential and light commercial buildings, and improving moisture-related durability and resilience of buildings following hurricane and high wind events. And then at the end, we're going to do some Q&A, and I think we're just going to get underway, and I'm going to stop my share right now and then let Stephen Swain start off with his tip. Okay. And multiple participants. There we go. Okay, Stephen.
Hi, hopefully this is working, and hopefully I remembered to unmute myself. Yes, I did. Okay, so we're good. So this is a quick talk to, let's see, is it working? It is not working. Okay, I'm going to stop share and try a different screen. Boom.
And we were seeing your screen just fine.
Yeah, it just wasn't shifting slides.
And now you're in, yep, there you go.
So I'm just waiting for this to hopefully, come on, there we go. Now is it shifting? Yes, okay. So welcome to our Tri-County Fire Workshop, and I'm just going to provide a quick overview. Most of you probably know this stuff, but it's just going to form a basis for the rest of our conversations, at least in terms of base knowledge. Okay, so we in California, as we relate to fire, this whole thing is part of a bigger picture. So as everybody's probably keenly aware, Native Americans managed the California landscape with fire for thousands, tens of thousands of years. And that worked out pretty well in terms of creating an environment that was at least survivable and in many instances pleasant for the people who lived here. Once European colonization set in, we had a bit more of a fire suppression policy. And in hindsight, that may not have been such a good idea. Fire touches virtually every potential landscape in California, every geographical region. And since there's people in pretty much all of California too, that means where you have people and land, you tend to have land policy. And that's where fire suppression policy came from in the last 100 years. And in hindsight, probably not the best idea. So when we're trying to talk about fire, speaking of bigger picture, the picture you see on your right is the California Public Utilities Commission. So this is the sort of intersection of fire risk as it relates to above ground transmission lines. So that's one lens to look at fire in California. And this picture will change depending upon the lens you look at it through. Fire, when we look at it through the Native American lens, was considered a community member. And that's a quote from Clint McKay of the Wapo tribe. He's up here in Sonoma County, does a lot of consulting work with Pepperwood Preserve, which many of you may be familiar with. Clint's well-spoken. And so he describes fire as a community member, almost like a person. But remember that the Native Americans viewed oak trees as community members. They were things that provided food. They were beings. They were related to in that way. And I'm not trying to put words in Clint's mouth. Maybe I should, maybe not say what they were and let Clint speak to that. But one of Clint's points is that if you exclude a community member, you can no longer work with them. We have been excluding fire from the California landscape for 100 years. And now we're starting to think that wasn't such a good idea. So maybe we do want to work with them. And that means including them. And that means we're going to have fire on our landscapes again. And that's going to change what we think we know. That's going to change our conversation. And it's going to change what we hope to learn. So for instance, we will not probably be working on how to build a better water bomber in the future. What we're going to be working on is how do we introduce fire in a way that helps us and we work with it rather than us fighting it, because we're kind of losing this fight as time goes on. And that's, so what do we want to talk to about today? Well, one of the things that I'd like to ask, you to consider is, how are you as a master gardener going to talk about fire to the clientele of your county and the people of California? There are a few fire advisors around. We have a couple of them here today, but there's only a handful of them in the entire state. So they can't do all the outreach. And that's where master gardeners really come into this picture. Okay, so to sort of frame what we're hoping to talk about, just a few pictures that most of you have already seen. This is a picture of the Camp Fire 2018 and its effect on Paradise. And I just want to ask you, what do you guys see here? And it's kind of a rhetorical question, because there's a lot of people and it's going to be hard to talk. So, but what it looks like to me is the trees aren't burned, the structures are. It looks like it mostly went from structure to structure to structure, and it didn't come from the trees. And if you're worried that maybe this is just one instance and maybe that's not the rule, let's go back in time and we'll start looking at it over. So this is Camp Fire in 2018. Here's the Tubbs Fire 2017 in Santa Rosa. Very different environment, but you can see where the fire was severe, it's mostly just houses. Where you have trees, and unfortunately the top of this image is cut off, at least from my view. Maybe you can see it. You should see a park up at the top of this image, and the trees there where there's lawn, and that's all fine. So really, one of the biggest problems that we're dealing with is it's the houses that are supremely vulnerable. It's not so much the landscape setting the houses on fire as vice versa. So going back even farther, this is the ranch. This is the Scripps fire in San Diego, and everybody's always telling me how dangerous eucalypts are. So here's trees within 30 feet of houses that burned, and the trees didn't even hardly scorch in this case. So, and if eucalyptus are really so dangerous, why did not one of them get lit on fire while all these houses burned at thousands of degrees within 30 feet of them, sometimes from the appearance of this, within 10 feet of them? So it does lead one to wonder. Just I'm not saying landscape doesn't matter, but what I am trying to say is that it's really the houses we need to pay attention to. So if we go back far enough in time, say 40 years ago, there were some the beginnings of fire safe plant lists, or at least advice in terms of what to do about your landscaping. And a lot of the early advice centered on not planting natives. I guess I'm not sure why that was. My belief is that it was based on the fact that California landscapes are fire adapted. So therefore plants in the California landscape must be fire adapted. And since the landscape burns, therefore native plants are bad because they burn, and that's the problem. And that was a little bit misguided, and if that's the case. So there was one nursery in particular, Las Palitas. It's a native plant nursery in Southern California that got a little tired of hearing this and did not believe that message, and actually set about conducting leaf burn experiments. And this is a picture of it. Now, the conventional wisdom was that plants with aromatic compounds in their leaves and that were drought tolerant and had hairy leaves or had other features, waxy leaves, would burn more intensely. So Las Palitas set about stressing some of their native plants, in this case, a native salvia, and they put a blowtorch to them. And what you found is if they burned at all, they had very short, sputtery flames that lasted a second or less and then went immediately out. And that the plants were really hard to burn, even with a blowtorch. What they also found is that annual plants, particularly weeds, burned really well, but that's because they're dead and they're only fuel at that point. There's no water conducting ability in them. So what we came away with was basically that species doesn't matter so much, and plant species doesn't. It's a little bit of a sidebar, if you will. All plants can burn, but a lot of the plants that we'd been saying were dangerous, as we looked at eucalyptus and now salvias, are not necessarily really the problem everybody says they are. So we've noticed that the plants lived, but the houses burned. Here's an example from the Oakland fire, 1991. So 30 years ago, we've been having this experience. And 90% of the ignitions are started by embers. And if Steve Quarles did a lot of this work, so if, and he's here today, we're fortunate to have him. So, you know, if we want to talk about those basics and revisit those, we've got the people here to do it. So why are all these ignitions started by embers? Well, houses are pretty good at trapping embers, and they're also pretty good at trapping live fuels. Embers may not ignite live plants very easily or at all. As you can see in this picture, this house, the one surviving house in this block in Oakland, broke all the rules in terms of defensible space. It's got ladder fuels. It doesn't have horizontal separation. The fuels are right next to the house. And yet, curiously, this is the house that survived. Well, one reason that this is a house that survived is the house is already fire hardened. So we've got a tile roof, we've got stucco siding, and we apparently had clean gutters. Now, houses are good at capturing fine fuels. Things like leaves and pine needles settle in gutters. And funny thing, that's exactly where embers settle too. They blow around on your roof, skitter off the roof into the gutters, get trapped in the gutters with the fine fuels, and that's exactly how you can start a fire in a gutter that hasn't been cleaned. But the interior corners of houses also work like this. They collect fine fuels and they collect embers. So those are great ways to start a fire. So this is why we say to start at the house and work out, because really it seems to be the houses that are the #1 problem. And landscape can contribute to that, certainly. But we want to start at the house and work out, harden or remove all structures within zone 1. If you can't harden it, then you should consider removing it. And if your house is ember hardened, you're already 90% of the way there, because that's where 90% of the ignitions are. But that doesn't mean you're safe from everything. So what are we talking from all fire potential routes? So what are we talking about? We're talking about some zones here. Tori's going to visit these a little more intensely, so I'm just going to introduce the concept and then I'm going to move on. Zone 0 is the most important zone. It's right next to the house. Zone 1 is within 30 feet. If you have structures, fences, things like that within zone 1, you need to worry about these. Zone 2 is a fuel reduction zone from 30 to 100 feet out. You should still treat that if you have that much space around your house. It's going to be critical to whether your house survives or not. But a lot of times in residential settings in urban areas, we don't have that much space necessarily around our houses. So I'll just let it go at that. The idea here is this. This is a image from a publication Steve Quarles authored, and I have the reference for it. It's the NIST 2020 thing at the very end, so you can pull this if you're interested in exploring this in more depth. But let's look at this point B that has a flame next to it. B as in Bravo. It's on the right-hand side of your screen. You can see that's where a fire started. Not terribly surprisingly, it's on the interior corner of a fence that and the fence is pretty flammable, so it'll carry that. And you can see that B1, B2, B3, this is the progression of the fire as it goes through. And it gets to sheds, it gets to houses via fences, and it destroys them if it successfully gets there. Or in the case of Residence 2, which is in the upper middle of your screen, it burned B1, B2, B5, B7, and it tried to get to, and the firefighters removed fence, and you can see it there on the left-hand side. And the house didn't burn because the fire couldn't get to it. And it survived the ember storm. And so everything was fine. Unfortunately for residents 3 and 4, because they were close to sheds and the fences led right to the house, didn't have separation at that last 5 feet or last 10 feet, depending upon how wide your gate is. Those houses were destroyed. And so the houses are the sheds and the houses are the other things that can lead to this. So we're talking about community in terms of houses and fences, but plants live in a community too. And this is what we're trying to avoid. This is Bishop Pine. It's listed by most fire safe and fire prone plant lists as being a hazard. And in this situation where the community is tightly packed and it's dense with fuels, it is absolutely a hazard. This is Point Reyes after the Vision fire, and they have since removed a lot of these trees to prevent the inevitable almost from happening, which is eventually you're going to have an ignition and this is going to go up, and I wouldn't want to be anywhere around this thing if there's a fire going. There is no way to stop this, a fire from going through this community. But is it really about the plants? This picture is of Bishop Pine as well. This Bishop Pine is alone. It's got vertical separation. It's got horizontal separation. It's in a golf course. It's on an irrigated landscape. This thing you would have a really hard time lighting if you tried. So it's really about design and maintenance. And those are the two places that we're going to be focusing on today, because while the house is really, really, really important, it's the first thing you should be looking at. That's not what master gardeners do. We're not house consultants. We're landscape consultants. So we're going to be focusing on everything after you got taken care of the house. And that is, you're going to be working on horizontal and vertical separation. I'll keep it, and keeping the landscape moist. So I want to point out also that in a lot of our developments, a lot of our houses are being built, the more modern houses, fairly fire hardened. Steve he can help you with details on that if you want to discuss it. But vegetation clearance in a place where the houses only have 10 or 15 feet between them may be less relevant in a high situation than what's going on with your neighbors' houses. So I want to point out that when you live this close together with people, you are going to survive or not as a community, because once one house sets on fire, it can be the thing that sets the next house on fire and the next, and the dominoes just keep falling. So whether or not your house burns has a lot to do with a guy that didn't clean his gutters 5 houses down. And you may need to address this as a community and talk to people. And if you've got folks that are financially challenged in your community, maybe everybody goes in on hiring a company to clean gutters for everyone and give everybody a break on the price, and you can fix it that way. I don't know, but you got to work together to be able to fix these problems. And that's in high density. This is a picture of a property on Healdsburg Ridge that survived the fire. You can see the scorch marks on these trees are 10 to 20 feet up those trees, but most of these trees didn't actually catch fire. They got scorched. They died as a result. Most of the houses on this ridge burned. This house didn't. And why? Look at the construction here. We have a steel roof. We have lime walls, lime walls are pretty similar to stucco. They're a little different. They're usually not painted. So they're dyed instead. And they work pretty well in a fire situation. And you can see this house survived. It's got all the requisite structural modifications needed to survive a fire, and it's got a clean landscape. And those are really mostly what you need to get by. So this is the Kincaid fire in 2019. So we've been looking back over 30 years or so of fire history, and we've been seeing some themes here. And we've been seeing a lot of houses that got destroyed. This is the first house we're talking about. Hey, this is how it survived. And in a rural setting, this is what it's going to look like. And in a urban setting, this is going to look like. So this is this year, Lahaina fire in 2023, and that is the quote unquote miracle house. But if you look at it, it's not a miracle. This house has a steel roof, it has stucco siding, and it has clearance. You've got ocean on one side, you've got a road on the back side, you've got an empty lot to the right. The only structure that is nearby that could have set this on fire is to the left, and you've got what looks like somewhere around 30 feet of clearance. So I'd argue this isn't a miracle at all. That house is 100 years old or so, and yet it survived simply because it's been retrofitted well, it's been maintained well. And that's why that one house made it. And I don't call that a miracle. It's not some crazy thing. Most of the rest of the houses around it, you can see, were much closer than that. And we don't know how they were built, though. Okay, so in summary, start at the house, fire harden all structures in zone 1. And that is something we're going to need to tell people over and over and over again. It is not the eucalyptus tree that is 2 blocks down that is going to burn your neighborhood down. It is the houses themselves that are the most vulnerable point. That doesn't mean they are the only thing that can burn. It just means that that's typically how they get started. So we're worried about community structure here. At the parcel level, we're worried we need to be putting our plants in islands. We want to have no fire ladders, and we want to maintain it in a clean condition with healthy plants. At the landscape level, we're going to use the landscape surrounding our house as context for developing our defensible space plan. We're going to be using natives that survive well in our environment. And if you've got land, you're going to develop and maintain that for defensible space. If you don't have a lot of land around, you don't have 30 feet of clearance, then you're going to need to work with your neighbors. And then finally, you need to think about escape routes. A lot of people in, say, the Paradise Fire ended up dying in their cars because they waited too long to go. And by the time they were notified or they figured out what was going on, everybody else was on the road too. So if you live in high density areas that don't have good, you need to think about getting out early. It's going to be key to whether or not you survive. And if you've prepared your house well in advance, it may survive just fine without you there. And that's all I've got. These are a bunch of websites that you may find useful. I know you've seen most of these. The 3 that you may be most interested are the Bethke, if you're interested in fire safe plant literature review, the Las Palitas burn time experiment, and the WUI urban versus rural parcel clearance. That's the document that talks about how much space you have around your house and what's the best strategy in those given spaces. And again, that's a Steve Quarles. He's one of the authors on it. Thank you, and I'm done. I'm stopping sharing.
Okay. Thank you, Stephen, for your portion of the webinar. And I am going to be handing off to Tori Norville, our fire advisor for Marin, Sonoma, and Napa counties, on some talking about Zone 0 structures. And Tori, are you ready to go? 1 second.
Yep.
Okay. I'm going to let you share your screen.
All right. Cool. Okay. So today I'm going to be talking about why my talk is on basically defensible space and the science behind it and some of the fire behavior. Hello. Boy, I'm having the same problem Stephen did. There we go. Okay. So I'm going to go over fire behavior 101, just giving you kind of a rundown of what factors go into how fire moves and behaves. We're going to look at some of the case studies, dive a little bit into those and the science, give a zone zero update, and just kind of talk about how that's fitting in with the other zones within defensible space. And then I also have some resources. I'm pretty sure you have a lot of them, but there might be some new ones. So fire behavior, and we're going to be talking about fire behavior. I have some videos with burn boards just to kind of get some of that live fire going into this. But first, just want to very quickly talk about fire in general. So we have fire is a chemical reaction at its basic level between oxygen, heat, and fuel, and that produces a flame. And then the byproducts of fire are smoke and heat, which feeds back into producing more flame. When we talk about fire behavior and how things burn, and particularly through like defensible space, we need to talk about the methods of heat transfer. And so there's 3 different ways heat can transfer along, and that's through conduction. So if you touch like a hot pan, that's conduction. Convection is the heat that comes up in the smoke column, and you feel it and it's hot. That's convection. And then radiation is when you're sitting at a campfire, you'll feel the heat on the sides. That's radiation. So knowing all of this, we can talk about the second triangle on this page of fire behavior. And the 3 components of fire behavior are topography, weather, and fuel. And I'm going to break down each one of these a little bit more. So first, we're going to talk about weather. I have some terms that you probably are all very familiar with, but they are going to set the basis for where we're at. So relative humidity, or RH, is the ratio of the amount of moisture in the air to the maximum amount of moisture that air would contain if it were saturated. This is normally expressed in a percentage. And we care about RH because it has a direct effect on the fuel moisture. So light fuels like grasses will gain or lose moisture more quickly with changes in RH, or while like large fuels like trees and shrubs, they'll take a little longer for their fuel moisture levels to change. Dead fuels and live fuels are also going to matter a little bit. Dead fuels are going to change a little bit more quickly, whereas live fuels, because they have that water transfer through them, aren't going to dry out as quickly, if at all. I think Luca might talk a little bit more about that. But fuel moisture just basically plays with the relative humidity, plays with the fuel moisture. That's why we care about it. Dry bulb temperature is just temperature. There's a wet bulb temperature that we don't really need to get into, but temperature is important just because it can help dry things out. If it's really hot for multiple days, it's going to dry things out. If it's cool, we don't have to worry that much. And then wind. Wind is probably the most critical factor affecting fire behavior, but it's also difficult to predict. This is because topography plays a lot with the wind patterns. So if you go on to some of the apps, like Windy app, there we go. Or even just Watch Duty, there's a feature that you can put on wind patterns. You can watch them curve around mountain ranges and see where they get funneled, and it's really fun and kind of nerdy. But wind plays a huge factor in fire behavior. I want to quickly touch on the critical fire weather, because this is what we've been seeing in the North Bay. 2017, 2019, 2020, all of our fires were kind of because of this wind events. I always pronounce this wrong, but I think it's like Fern winds. Basically, what happens is there's a high pressure system sitting over the Great Basin, and then low pressure systems to the east and west. And air is kind of like liquid, and it wants to equalize. So think of the high pressure as a glass jar with a lot of water in it. And then the low pressure systems are a glass jar with like half full. And then you put a straw through them and they're going to equalize. That's kind of what's going on with this wind events, is they're trying to equalize. But they have to go over mountain ranges, so they get funneled and they have to go up and over. And so they increase in speed, and then we get the weird winds, or what I call the freaky winds. If you're in Southern California, you're going to see Santa Ana's. Up north, we call them north or Diablo winds. So that's kind of what we see through here. Topography is basically whether you're not in mountains, in a valley, flat, hilly, aspect, slope. For the master gardeners, I think slope is going to be your most critical thing that we need to talk about, because slope affects fire behavior pretty drastically. So fire will start, if a fire starts at the base of a hill, it'll go up, and we have what happens, or what we call preheating. And so basically that's through radiation and sometimes convection. The material in front of the fire will heat up to the point of it just rapidly combusts when the flame actually hits it. And so I have a couple videos here that I'm going to start. They're both set up the same fuel type, same pattern. The only thing different is the change in slope that we did. And you can see the flat, a couple things are going, the flames are pretty high up. We were playing with wind a little bit, but not much that day. On the bottom screen with the slope, you can see the flames kind of lean over and start to touch the matchsticks above them. Whereas the front ones, they just went straight up. They didn't really lean over that much. So this is how slope kind of plays with fire behavior and drives it a little bit. Okay. Stephen Swain touched on this a little bit, but ladder fuels and spacing are important. So again, I have another model for you. I like visuals. This would be an example of maybe like a yard that's been overgrown, not managed, not maintained. There's no spacing, everything's very tight together, and you just see kind of rapid ignition occurring. This is why spacing is important. So I'm gonna skip ahead. I didn't figure out how to edit the video. So at the end, everything's kind of burnt and crispy. So then we're gonna go look at what happens when there is spacing. And again, these are all things being equal. Like, we're not adding the slope to this. We're not adding the wind behind it. This is just kind of to see how each individual leg of the fire behavior triangle behaves just by itself. So when things are properly spaced, we're not trying to stop ignitions in our yard. We're just trying to contain them such that they don't move around. And so everything just kind of stopped right there. Oh, sorry. Okay. So spacing is important. I'm sure you've all seen these charts and graphs, and I want to stress that these are just kind of best management practices. They're guidelines. They're not the end all be all set in stone space to this spacing. What I like about this graphic right here on tree spacing is it kind of introduces this feathering effect. The closer you are to your house, the more space you're going to want. Whereas the further away, you don't have to be as spaced. Still want space, but you don't necessarily need to have as much space. Next, we're going to talk about how houses burn. Stephen talked a little bit about this, but I want to give a little bit more context. So there's 3 ways that we have houses burn. First is direct flame contact. Second is embers. And third is radiant heat. And so we have been seeing all 3 of these occur. Direct flame contact can be mitigated through defensible space, because that defensible space breaks up the continuity, breaks up the fuels, and allows firefighters to get in there and work. It creates kind of this safer environment for them to work in. Home hardening can help with embers. Embers come in and they can ignite in your gutters, along your zone 0 areas. But embers can also ignite in the yard in like patches of receptible fuel beds. So in mulch or in dead leaves, dead material. So they can start there. And this is what we call indirect ember exposure. So basically, So basically they ignite in your yard and then the fire progresses through direct flame contact to your house. Home hardening and defensible space can mitigate both of those. And then radiant heat is what happens when like a shed or fence burns, and then that heat is so intense that it preheats your house and ignites it. So home hardening and that 5-foot defensible space or zone 0 can really help with those radiant heat exposures. And we'll discuss this a little bit more in our next couple of slides through case studies. Sorry, that was weird. My ceiling just like made lots of noises. So the first one I want to talk about is lessons from California. And this picture is from Paradise. So Stephen kind of set the stage with Paradise. There was a research paper that was conducted out of Paradise. And what they found was that there is a neighborhood effect out of Paradise. And it's probably true for some of these other fires that we were seeing. But what they found in Paradise was houses that are less than 18 meters apart were damaged or destroyed through radiant heat transfer. So basically, embers might have set a house on fire. That house was on fire, and because it was so close, it started igniting all the other houses in the neighborhood. We know embers were there because we have pictures of embers on the cushion. And I just want to point something out here, because I always think of embers as little campfire embers that you see, and they're like firefly looking. These embers were massive. So we're talking large embers. In the car fire in 2018, so this was up in Reading, and we have other examples of this as well, where vegetation was in front of a window and the window cracked. This is why we ask for double paned windows, but also not putting vegetation in front of windows is going to help increase the survivability of those windows. We're seeing the same things in Colorado. There was a fire in 2021. This fire was in December. It was either right before or right after Christmas. And they had those freaky winds. It was trash night, so everybody's trash was blowing around, great receptive fuel beds. And what they were finding was embers went to the plant, to the vent, and the house was damaged. You can see that there is some non-combustible mulching going on right here, which is fantastic, but we still had those large woody plants. So the plant ignited, hit the vent, and went up. This tree right here, or this stem, is this tree right here. And again, we were seeing embers to plant and then up to the soffit. And there's some window damage and damage down here as well. The boulder fire also kind of helps show the role of fences and wind-driven fires. So if the fence is parallel with the wind, so running with the wind, fire behavior will increase and move very rapidly around the fence. If the fence is perpendicular to the wind, so the wind's going into your fence, your fire behavior is going to decrease and not spread as rapidly. And we'll talk a little bit more about that because there's some science to back that up as well. But with this fire, you can see some burnt fence posts here. The fire moved very rapidly around the fence, and then the fence was attached to the house, and so it damaged the house. We did have some examples of zone 0. Around this house here, it had no firefighter help, and it survived. There was a 3-foot non-combustible zone around the entire house. And then this is the backyard. It's got pretty good zone 0 going around, and increased zone 0. It's got some cushions out here, but it survived. In the front of the house, we had, or you can see they had planter beds, and there was some burnt vegetation. I don't know if the windows were cracked or not, but we can see some evidence of ember accumulation smoldering at the door. And it was Christmas time, so there was a lot of decorations, and I think they were starting to clean out the house or clean out the yard or something. So zone 0 kind of helped it a lot. I know everyone has seen this picture. I like it because it shows us where embers accumulate and where they kind of eddy. So you can see them kind of eddying here and eddying over there. And Steve hit it on the nose of wherever you get wind pushing debris, leaves, dust, whatever, after a really windy day, that's where your embers are also going to go. So be sure to clean out those spots particularly regularly. That's kind of my spiel for embers with that. So some of the science that's coming out of IBHS, which is the Insurance Institute for Business and Home Safety. And this is where Stephen Quarles, I don't know if you still work there, but he's on some of this research, and it's really cool. So basically they took these burner boxes and set them up at different distances away from a building and tested different building exposures. So like a middle of a wall, I don't remember what those ones were, but this is a corner. And for most of them, 3 feet was okay, you're safe. But for whatever reason, at this 3 feet, the wall was starting to get heat up to the point that it could ignite. And so they bumped back to 5 feet, and the walls stayed fine. They didn't heat up as much. On the corners, we're seeing a little bit different story. At 3 feet, it ignited. At 5 feet, they were still having that problem where it was getting too hot, not necessarily igniting yet. And then at 7 feet, it never hit that critical temperature of 200 degrees Celsius. The corner is with the wind flow, it increased the flame impingement angle markedly, which increased the potential for direct flame contact to the building and intensified the thermal radiation. So basically, the wind was adding to the flame impingement and causing it to heat up a little bit more at 5 feet. The law will still say 5 feet. But what we could do here and what could get interesting is we can introduce that feathering effect again, create movement, have maybe like weave in and out type of stuff, offset larger vegetation off your corner a little bit further. I think there's room to play with this a little bit. There's been a lot of research with fences in Zone 0 coming out of IBHS. They replaced the gate with a metal gate and ignited a fence, and it stopped at the metal gate along with having non-combustible material on the ground. The National Institute of I think Business and Technology, I can't see it, NIST, they've also been doing a lot of research on fences and mulch. There's a 400-page document if you want to read it over here on it, but they're really finding that your fence design and your materials will play into how the fire behaves through your fence and burns through the fence, and whether or not that fence will produce embers. And then they're also finding that same thing that we found in Boulder with, if fences align with the wind direction, it's going to increase your fire behavior. Whereas if they don't align, it's going to decrease the fire behavior. So some Zone 0 updates and just defensible space in general. Quick overview of what each zone is. So Zone 0 reduces the likelihood of structure ignition. This is your last chance defense of a fire moving through your yard. It's your do not pass go. You will stop right here. That's how I view Zone 0 is I will stop the fire before it touches my house. Zone 1 reduces the likelihood of fire burning directly to the structure because you're breaking up that continuity, you're creating space. And then additionally with that Zone 0, your do not pass zone, you're just reducing the likelihood that it can get to your structure. Zone 1 is also where firefighters are going to be working. So you're creating extra safety zones for them. You're creating just a workable environment for them. Zone 2, if you have it, are actions designed to reduce the potential fire behavior of an ongoing fire. So think of Zone 2 as your shaded field break for your Zone 1, where firefighters are going to be working. If you don't have all this space, like Steven said, work from your house out, work with the space that you have. Once you get your place set up and in a good spot, go talk to your neighbors, figure out what they need help with. Maybe they don't fully understand the rules. Maybe they don't have time. Maybe they don't have the money. Again, work with your neighbors, work with your community, figure out how to make it work. So Zone 0 updates, I don't have a whole lot. The law will address everything in green. Everything in this pink is things that could show up in a Zone 0, but they're not going to be addressed in Zone 0. I think this is something that the master gardeners could help come up with some best management practices for these pink topics. I think they might become addressed later on with some updates to Zone 0. I don't know. But that's kind of where we're at. Also right now, so Zone 0 is at a standstill very high up in the state. We're not sure when it's going to be rolled out at this point, and we're not sure how it's going to be rolled out at this point. My recommendation to you right now is to call your legislators and get them to get this moving again. Until it rolls out, at this point, Zone 0 is just best management practices. And so really having you master gardeners kind of help us get that information out and telling people like, this is best management, this is best practices. It is really going to be helpful for when this does finally roll out. Hopefully it won't be too much of a shock to people. So there is going to be some pretty strict restrictions on height and spacing in Zone 0. That's different in Zones 1 and 2. Zones 1 and 2 do not have height restrictions. They don't have spacing restrictions. It's just kind of best management practices at this point in there. Those might change down the line. No one's really talking about it right now. So this is just kind of a interpretation of how we would like to see stuff is in zone 0, you can have flammable materials, but they can't be higher, ground cover can't be higher than 3 inches, and plants are going to have a height restriction as well with spacing. Then we get into zone 1. Again, remember, there's no restrictions on setbacks, there's no restrictions on heights. What we don't want to see is just a wall of vegetation at 5 feet. So again, feathering effect, kind of work it in, weave it through. If you have a tree at 5 feet, you don't have to cut it down, you don't have to move it. Maybe don't plant a new tree at 5 feet, but again, there are no restrictions. This is just kind of a different view of it, but again, that feathering effect, layering, smaller things around your house or in potted plants that you can move out on different days. And then finally, resources. I'm pretty sure all these were on the list that we sent you earlier. These resources are the ones that I pulled for this presentation. All the ones in the gray boxes are some of the research papers that have been coming out recently. And then finally, feel free to email me with questions. I'm happy to help, and this is my area, so I'm in all 3 counties. And with that, I'll stop sharing.
All right. Thank you very much, Tori. Really appreciate that presentation. Next is going to be Luca, and I'm going to let you get queued up and ready to go. So Luca Carmignani is the Assistant Fire Advisor in the South Coast, working out of Irvine. And oh, okay, we're all ready to go, and I'll let Luca go. Thank you.
Sorry. I was just trying to
That's
pull
awesome.
the presentation.
There we go.
All right. Good morning, everybody, and thank you for having me here. I'm Luca Carmignani, and today I wanted to talk about my research project on plant flammability. And for those of you who don't know me, I'm a fire advisor based at the South Coast Research and Extension Center in Irvine, but I cover multiple counties in Southern California, San Diego, Orange, LA, and Riverside, which give me that cool acronym, the solar counties. And my work focuses on wildfire preparedness, especially home hardening, defensible space, but I also collaborate with fire agencies, organizations, and communities to promote fire resilient landscapes. And I've been in this position for a little bit over a year. And previously, I was in the Berkeley Fire Research Lab at UC Berkeley, and I received my PhD from UC San Diego and San Diego State University in mechanical engineering. And yes, I'm Italian, and that's where I got my bachelor and master degrees in aerospace engineering. So let's talk about plants. And we've seen a few examples in the previous presentations, but I wanted just to step back for a second and just think about why we want plants in the backyard or like around our home. And there are multiple benefits for it besides aesthetics. They provide shade, they provide habitat for wildlife. They have all sort of benefits. So it is normal that we do want to have plants around our homes. At the same time, from a fire perspective, having plants in certain conditions can be problematic. So what we want to do is we want to manage the benefits versus risks. And how do we do that? Well, one way to assess the risk of a structure, for example, is by talking about plants' flammability. And by knowing how flammable a plant is, we can design guidelines for creating fire-resilient landscapes. These guidelines could be useful both for residents and also public officials. For enforcing some of the regulations, for example. And also knowing more about plants' flammability is very important because a lot of models that predict the spread of fires in urban areas are based on models that work for the wildland space, like open spaces. So in urban areas, though, you have a variety of vegetation, you have homes, you have structures. So understanding the interaction between plants and structure will be also very beneficial to better understand how these fires spread. And how do we communicate these results on plants flammability? Well, I'm pretty sure you're all very familiar with plant lists, and these are very common, and overall they're nice and have some pros. For example, plant lists are usually easy to understand, so they provide a good base for regulatory and educational efforts. And if there is a resident that doesn't really know where to start, it could be a good resource, for example, to design a backyard, or, you know, just having something to start with. And also another nice thing is that these lists can be combined across different objectives. So for example, you can have fire resilient plants, and you can have drought tolerant plants, or, you know, plants that help with the wildlife ecosystems. So you can combine multiple objectives. And unfortunately, though, these plan lists also have some issues. And besides the fact that every plant can burn in certain circumstances, the main issues, in my opinion, is that these lists do not provide information about how they burn. They only give you an idea if they burn or not, but, you know, not all the plants are created equal. So you have some plants that burn better than others. And also another big issue is that these recommendations are not really based on scientific testing in most of the cases. And so there's no standard practice on how to evaluate the flammability of these plants. And also another critical point is that usually they give you a snapshot, like a instant picture of flammability, but this is something that could vary during the year or with the age of the plant, for example. So these are information that are really hard to communicate in a list. But okay, so what is plant flammability in the first place? And is not a single parameter. So that's also why it's hard to find a definition, and you find many different approaches. And historically, some flammability components have been identified based on the testing procedure and the behavior of the plant. And specifically, usually we look at how easy it is to ignite a plant. For example, if you have a ground fire that is spreading towards it. So how long will it take the shrub to ignite, for example? But this is something that also depends on how you ignite it. For example, between embers or a flame contact, you might get different times. And another important aspect is the rapidity of the flame spread. So how fast will the flame spread from the grass, for example, to the shrub, and how much time will it take to burn the shrub completely? So these are all important aspects. And on top of this, another important aspect is how much of that plant will actually burn, and what is the residual mass after it burns, because that gives us an idea about how much heat that plant releases. And we've seen, like, Torium's presentation talked about the different kinds of heat transfer. So we can connect the dots by knowing how much of that plant burns. And unfortunately, there is not really a standard testing methodology. So we usually find this information that are based on observations or qualitative behaviors. So my job is to work in this direction to create more quantifiable results. And one of the main issues is that flammability, again, as a full set of parameters, not just a single parameter, depends on a lot of factors. And some of these are the species of the plants and the plant traits, not only as a species itself, but you should see it as, you know, the structure of the plant, the age, the amount of that material that it has. And also, these factors might change during the year. You know, in an open landscape, you have precipitations, but if you go close to your home, you might irrigate your plants. So how does irrigation affect this flammability? And another important factor is the size of the plant. A small shrub might behave differently compared to like a bigger shrub. The bigger one could be older, so it might have more dead materials. So size and also the spacing between different plants is very important, because if you have two shrubs, for example, that are very close to each other, as Tori showed in her video, you know, if you have the matchsticks that are pretty close, they can propagate the fire better in compared to if you have the sticks far apart. So the same concept applies to plants. So I wanted to show some of the results that I gathered in collaboration with UC Irvine last year. And this was a preliminary study, and we wanted to look at the effect of irrigation and sun exposure on the flammability of plants. And when I started as a fire advisor, I was very lucky because there was already an ongoing project at the South Coast Rec. And this project is called UC Landscape Plant Irrigation Trials. And it's a project that looks at multiple species of ornamental plants, and over the course of 2 years. And these plants are exposed to 3 irrigation frequencies. And one of the objectives of this project is to find what plants behave better in a drought, during a drought, basically. And because these plants that are more appealing will likely be more selected by residents and landscapers for their communities. And so the objective of the study was, first of all, to find a way to measure the plant flammability and sort of find a realistic way to take into account of several factors, and to study also the effect of these 3 irrigation frequencies and the sun exposures. Because if you see here on the picture on the right, there were some plots that were in full sun exposure, and like the one at the bottom right, where the plants that eventually burned were. And then there was another plot at 50% shade with the same plants. So this was a great control method to study the effect of these 2 parameters. So the testing conditions, originally I was planning to burn as many plants as possible with multiple varieties and you know, different sizes. The fire marshal was not that happy about my excitement, so eventually I had to scale down the project a little bit in order to make sure that safety was guaranteed. So I eventually selected this Penicillium plant, which looks like a grass-like ornamental plant, which is very, very common in Orange County and Southern California in general. And these plants were exposed to 3 different irrigation frequencies, which corresponded to 80, 50, and 20% of the evapotranspiration rate, which kind of translated to basically having these plants that during the months between May and October were irrigated pretty much once a week, once a month, and once in the whole summer. And this is not like a necessarily a correlation, but that's more or less these frequencies, how they translated. And these plants, again, where some of them were exposed to a full sun exposure and other ones to 50%. And we had about 6 to 8 plants per condition. So for each of these conditions, we had 6 to 8 plants that were in the same, they grew similarly. And for the experiments, we wanted to have realistic experiments. So with the plants exposed to, the whole weather conditions, and so we wanted to burn these plants in an open field, and we wanted to burn the whole plant and not just like a small sample of it. And for the ignition method, we ended up deciding to have a flaming ignition, and where I manually basically ignited the plants with a propane torch. And again, the idea was to burn these plants in a more realistic scenario as possible. So we wanted to burn the plants on site, and ideally we wanted to dig out the plants and burn them right away. Unfortunately, by the time that I got the burn permit, the rain season had already started. Oops. And we had an early start last year. So these plants, that by the way were 2 years old, we decided to remove them from the field for a few days before the experiments because there was more rain expected. So we stored them in a greenhouse for 4 to 7 days. And in this greenhouse, we were able to do some more measurements, for example, the moisture content and the mass of the plants on the day of the testing. And then after storing them in the greenhouse, we brought them back to the field and we burned them in an open field condition. And we burned about 9 to 12 plants a day. So it took a total of 4 days to burn the entire set of plants. And the experimental setup was pretty straightforward. We basically just put the plants on top of a gravel surface, and we had 2 cameras that recorded the experiments from 2 different angles. And we also had 2 sensors that measured the heat flux. And the heat flux is basically just the amount of energy, the heat that you feel that is coming to you from the plant. And Tori mentioned this, there are different kinds of heat transfer methods. And what we were trying to measure was the radiant heating, the one that, you feel even far away from the plant. But also, there was the smoke column that sometimes would change in direction. So if we hit one of the sensors, we will measure also that convective heating as well. And these sensors were placed 4 feet away from the plants. And we also had an anemometer, which basically measured the speed of the airflow around the flame very close to the plant, again, like 4 feet away. And these are some of the results before burning the plants. And I apologize that the graphs look a little bit crowded. But what I really wanted to show here is that we basically measured the weight of the plants each day before burning them. And on this graph, you find on the y-axis the initial weight. It's in kilograms, but you can roughly multiply by 2 to understand like the weight in pounds. So for example, 10 pounds is about 20-ish, 10 kilograms is about 20-ish pounds. And what I really wanted to show you here is that the triangles are the plants that were grown in full sun exposure, while the circles that are more at the bottom were the ones grew in the shade. So overall, we had the plants in the sun, full sun exposure were bigger than the ones that grew in the shade and almost double the initial weight. And we also measured the moisture content. And as Tori mentioned in her presentation, the moisture content kind of indicates the amount of water that is in the plant. So it translates to the amount of heat that it can release when it burns. And again, the graph is a little bit crowded in symbol, but what I really wanted to show here is that there wasn't a really big variation between sun exposure or ignition frequencies, but overall you see this decreasing trend of the moisture content with the days that the plants spent in the greenhouse, which makes sense because the plants were just dug out of the field, they were still in a greenhouse, so they were getting drier and drier. And by the way, related to the symbols, so the triangles correspond to the ones in full sun, and the darker the symbols are the more irrigated plants. So you have the darkest symbols are 80%, the medium symbols are 50%, and the lighter symbols are 20%. So pretty much once per summer. And so in this slide here, I wanted to show you a little bit how the experiments worked. So here there's me igniting the plant at the bottom with a propane torch, and it didn't take much for the plant to start burning completely. And here on the right, you see on the y-axis, the total heat flux that we measure with the two sensors and its variation in time, basically. And here you can see that we have the two sensors that were at 90 degrees angle that grow in the same way for the first 15 seconds or so. And then you have a variation between the two signals until the end of the experiment. And this indicates that sensor 2, in this case, the orange triangles, very likely got engulfed by the columnar smoke from the plant. So we got that radiative component of the heat plus that convective heating that came with the smoke. So that's why we have these higher values compared to sensor 1. And to have a first analysis of the data, we considered the maximum heat that was generated by the plants, and we try to compare it to the different conditions. And so if we first look at the data for the full sun exposure plants, we have the maximum total heat flux on the y-axis and the days that the plant spent in the greenhouse on the x-axis, so from 4 to 7. And again, it's hard to see any trends that is due to the irrigation frequency, but overall you can see that by increasing the day in the greenhouse, the maximum heat flux kept increasing. And if we add the plants that grew in the shade, again, like we don't have much variation between the irrigation frequencies, but we have this overall increasing trend, which makes sense, but that basically the drier plants release more heat depending on the time that they spend in the greenhouse. And this is a graph showing the same data of maximum heat flux as a function of the moisture content. So there's a lot of data scattering, but overall you can see that the drier plants tend to have higher heat fluxes. And so this red line shows a little bit of a trend of a decreasing heat flux released by the plant for higher values of the moisture content. So the more water in the plants, the less heat release, which makes sense. And another aspect I wanted to show is how long did the plants burn for? So we considered the start of the burn when we ignited the plant and the end of the burn when the flames kind of went away, and we didn't consider the smoldering part. And so it was interesting to see that we had a lot of variation on the first day, depending on the sun exposure and irrigation. But overall, these data tended to get closer and closer together. And overall, the burning time got shorter and shorter with the days in the greenhouse. So how can we summarize these data from this preliminary analysis? Unfortunately, irrigation did not show a big impact on the results as we hoped for. And it was also interesting that plants that grew in 50% shade actually showed a pretty similar values of maximum heat flux compared to the ones that were grown in full sun exposure. So that is not something that we really expected, but definitely moisture content and greenhouse days were some of the driving factors of these experiments. And so this is kind of indicated that unfortunately all the rain that we got before the experiments very likely impacted the results and made the importance of the irrigation frequencies negligible. And because the plants very likely were saturated from all the rains that they got. And also the size of the plant, I mentioned that the plants that grew in the shade were smaller. The size of the plant and the method of ignition, which was me igniting with the propane burner, probably could have affected the results as well. So how can we improve from here? Well, we want to repeat the experiments this coming fall. And for this new set, we are working on creating a new experimental setup. We're gonna have a metal structure that is gonna be mounted around the plants, and we're gonna have a propane burner for ignition. So hopefully we would have a more standardized and more repeatable ignition method. And we're also gonna have a lot more measurements. And I mean, we're gonna gather a lot more measurements. We're gonna have a scale to measure the amount of mass that changes in time for the plants itself. And we're gonna have heat flux sensors, that are gonna, sorry, got a little bit stuffed up. They're gonna distinguish between convective heating and radiative heating. And we're also gonna have an infrared camera to study how the different parts of the plant heat up during the combustion. And we're hoping to have at least 3 plant species this year. And that again will be affected to 3 irrigation frequencies. And the plan is to start burning at the end of October and probably for the first couple of weeks of November in 2023. And just to give you a quick peek, so these are the plants that have been grown at the South Coast Rec. And so here, for example, you see this is a red lantana, and this is a grass type. I think the common name is stilbit grass. And these are great candidates for this year. And I probably gonna need to find a third candidate. But as you can see, I have plenty of options here. And yeah, so that's the situation now. And I apologize, this was a pretty technical presentation, but if you have any questions, please feel free to reach out. You can scan this QR code and it will show you a screen like this. So you can find my contact on social media or my contact information here at the bottom. And yeah, thank you for your attention.
Thank you very much for presenting that presentation and your findings and your studies. I know master gardeners have a saying, right plant, right place, right care, and this really contributes to the understanding of how we can best advise in that situation with some of the studies that you're putting forth. And yes, okay, stop share. And I think we have Steve Quarles next with his information, focusing more on mulches and a mulch study that's being conducted in Marin County as well. And it looks like you are about ready to go, Steve. Okay, so I'll hand it off to you.
Thanks very much, and thanks for the invitation to speak today. Today I'm just going to talk about some studies that have occurred with mulches, and in particular focus on what's coming up with the mulch study in Marin County. It's going to take place in early October, and it will be sort of in West Marin. The picture on this screen is the mulch study that I conducted with my colleague Ed Smith at the time with the University of Nevada Cooperative Extension. He's now a happily retired guy, but we did a similar study in 2008, this one, and we're going to repeat with different kinds of mulches and building on some of the information we determined in the Nevada studies was conducted in Carson City. So let's see here. Okay, I'm going to start by showing a video. This will be somewhat repetitive, I suspect, based on what just happened, but but you'll hear me talk about stuff. And this is the reason why we're concerned about, in particular, near home mulch. So I'm going to turn the sound off. This was one of my first projects when I joined IBHS in 2011. And this was more of a demonstration, but you're seeing the first generation of the Ember generators getting loaded up at the beginning, and then we're sort of putting various kinds of mulches around the test building. These are the generators working. The guts of them are below grade. All you're seeing above grade are really the vertical duct. You're going to see now embers igniting things. This would be vegetative debris on the roof, in the gutter, and on the roof. And then you'll notice fire starting in the mulch right next to the building. So these, as Torian indicated, are examples of indirect ember ignition. So embers ignite something. That something provides a flame or radiant heat exposure to the building. So you see a fairly involved mulch bed with the vegetation that was sort of planted in it. Again, the debris on gutters and in roof, igniting and burning, edge of roof, on the roof. And that's an interior corner. Fires can get pretty big in interior corners. And at this point, since we still wanted to use this building for other experiments, firefighters are going to put it out here in just a second. So I'm going to stop. This is, again, just the ease with which embers can ignite mulch and the why we are concerned about them. And just not to pile on, but again, embers igniting. This is a 2019 demonstration, again, at the IBHS research facility, which is located in Richburg, South Carolina. It's a smallish town in South Carolina, about an hour south and a bit east of Charlotte, North Carolina. Anyway, embers igniting mulch, and then that flames from that burning mulch igniting the siding, flames spread on the building, and entered this test building. Fire entered this test building one of three ways: breaking glass in the window, entering through that gable end vent, and then entering through that under eave area on the gable end side of the building. You could say, well, just use non-combustible siding, and that would be a solution. But it'd be a more expensive a solution if you already had a house. And if you're like me, you already live somewhere. It'd be a more affordable solution just to remove the combustibles near the home. So that's another thing about the mulch. This is a 2012 Waldo Canyon fire. You may remember that in Colorado Springs. This is a post-fire assessment team I was a part of. And you'll notice the rock mulch sort of closer to the house, and then mulch beds that were ignited and burned some vegetation in those mulch beds away from the home. This is similar to what Tori had indicated. You don't mind ignition of islands of vegetation as long as those burning islands of vegetation can't threaten the thing you're most worried about, which is your home. So this is just that example there. It ignited that island, and then it was done. But it was definitely an ember ignition of mulch, because you'll see vegetation behind and green grass sort of behind these mulch beds. The fire didn't burn through those trees across the vegetation into the mulch bed. It was embers from fires burning out that landed in the mulch bed, ignited that, and then ignited the vegetation within that island there. So discontinuity is really good when it comes to plantings on your property or on a property. This is another example of 2009 Highway 31 fire in near Myrtle Beach, in the county that Myrtle Beach is in, South Carolina. And again, on the left, yellow circle, green grass, red circle, ignited and burned mulch. Roughly 70 houses were destroyed in this particular fire. An example of one of those houses is on the right. This house on the left was damaged. There's a sort of a saying that I attribute to Alex Marin, a researcher at NIST that has done a number of post-fire assessments. If you've looked at all the post-fire assessments, you've come across Alex's name. He was the co-author with myself and others on the, he was the lead author on this NIST Technical Note 2205 that Stephen had mentioned earlier on. But the saying is that damaged equals defended. And that's an example here. Usually houses that ignite in a wildfire are completely destroyed. But if they're defended by a firefighter or a homeowner that has decided to stay and defend and is successful, then those are the situations where homes are damaged rather than completely destroyed. If no one's there, a small fire becomes big, and that ultimately leads to the total destruction of the home or a building. So somewhat similar to what Luca was just talking about, this is part of that experiment that you saw in the opening clip. But in this case, we are trying to ignite various kinds of mulch. And I think the bottom line is that every kind of mulch ignited via the ember exposure. And typically, as is indicated with Luca's graph, it's kind of a spiky thing. It builds quickly and it drops off. If this were a big wood pile or a tool shed or a neighbor's house, then it would climb sort of slowly, and then it would be a rather more constant heat release rate and then drop off, but it'd be longer duration. In the first clip, you notice that it kept going for a while, and that was just because of the amount of mulch in terms of depth and the width of it along the house. But typically vegetation and vegetative fuels in general are kind of spiky in terms of heat release rate, which is sort of good. But if it's really a high heat flux, then it can still result in ignition. So I'm going to just talk a little bit about the mulch burns in the 2008 study. These were largely mulches you would find more commonly in the Lake Tahoe Basin area. Ed had access to a place in Carson City where we could lay out these mulch beds, let them sit for a while, and then come in later and burn them. And these are examples of that you're seeing here. We ignited with a drip torch. You can see the firefighter with that, and then we used fans to have a more repeatable wind speed. The purpose of the circular bed is that you could ignite the fire in the direction of the prevailing wind. And so the circularity of it made it easy to just move the ignition point as a function of where the wind was coming from at the time. And we did do that. This particular design feature was used earlier in a study that was conducted in Florida, and we used, I'll talk about that one in a minute. And we just used that design because of this ability to orient the start of the fire as a function of prevailing wind. These were the mulch types that we used. Composted wood chip, we used one of those. Then various kinds of locally available mulches. Tahoe chip there towards the bottom is just stuff that was chipped. And so it was many things, whatever was happened to be chipped during fuels treatment projects. And then pine needles in the South, this is called pine straw. That first, the Myrtle Beach fire, the common mulch next to the house would be pine straw or these thick bed of pine needles. And then we also used a commercial product of rubber mulch. You've probably seen it. I don't see it. I think it's too common these days. I don't see it so much, but it was reddish in color, but it was just recycled rubber. And this was a sort of a summary of the results. And you'll notice that there's some variability in terms of flame height, flame spread, and temperature. Our temperature was mostly with heat-sensitive paint. So that's one thing we're going to change is upcoming study. And you'll notice that Luca had a better way of measuring temperature. But you had a range of performances from it burned pretty well to it didn't burn well at all, and the range in between. This is the rubber mulch product, rapid flame rate, and so it moved along pretty quickly. The flame heights are pretty tall. Although the flame length was probably a better measure just because of the influence of the wind, and it was a very dirty fire, as you can see with the black smoke. And at the other end of the spectrum was this composted mulch product, and it never flamed. It smoldered, and so it was a pretty hot fire, but it was a slow-moving fire, non-flaming fire, and should it meet something combustible along the way, it was hot enough to ignite it. So if you had siding going all the way to the ground, for example, and this smoldering fire reached the siding, it was hot enough that it could ignite that siding, and then it would be a different story in terms of what kind of fire would ensue, because it would really depend on the combustibility of the thing that it met. But this was the better performer of all of them. And this is the Florida study that was conducted by a number of NIST and USDA Forest Service researchers. And as you saw in Luca's presentation, they were interested in the various components of flammability. This is based on Bob Martin's paper in 1994, where he and his co-authors came up with 4 things to monitor. So how easy it is for the thing to ignite, how long did it burn, what the heat release was from it, and then how much of it was actually consumed in the end. If you've seen pictures from wildfires of fires burning through shrub or through forest, you'll observe that the small things burn, the big things, branches and trunks don't burn. And so, the consumability would be not so much, although, definitely you can do some damage, but so that's sort of the measure of the consumability part, is how much of the thing actually burns. And there they used a few different kinds of mulch, and they rated each one and with these 4 factors that Martin had identified, and that I think you'll sort of remember, maybe with somewhat different terminology, but the same kind of things that Luca was talking about in his presentation. So I don't want to dwell on this. I mean, I think that the bottom line is that mulch will burn. Mulch is easily ignited, and the question is the right plant, right place, right mulch, right place. We want to better understand that. There's a fairly interesting study about 10 years ago now was published, and it was trying to propose a standard way to evaluate mulch, and both in terms of ease of ignition from embers, and once it ignites, or what the flame spread might be. And so they use different things to mimic or to be a surrogate for windblown embers. and those are on the left-hand side here. I don't know if you can see my cursor, but the picture on the left, they used standard brands that are used in roof tests. So if you've heard of a Class A roof covering, then that would be this lower right-hand picture size of a branch. You could put a burning one of these guys on your roof, and it won't burn through into what would be the attic. There's a Class A, Class B is this right-hand picture, lower right-hand picture on the left-hand set. And then a Class C brand is this upper picture on the left-hand set. And they cut that Class C brand into a quarter and then to an eighth of that quarter. And they burned these things and put them in the mulch bed and then evaluated performance based on that. We know, I think, Tori had made this pretty clear in her presentation that embers can be small. Some of them are larger. I think some studies that we did while I was at IBHS indicated that vegetative fuels, the ember sizes are relatively small. When you start burning buildings, that's when the embers get larger. And, the embers from vegetative fuels are typically cylindrical because branches are cylindrical. And when you get to burning buildings and the like, you can have more plate-like embers that can loft further. They can be larger. So plywood, for example, lumber is just bigger. So when you start detaching bits of that, then you can get larger embers. So typically when you have larger embers, you have buildings burning. I think that's sort of the bottom line. And then the left-hand picture on this slide, the right-hand picture, the flame spread picture, they ignited this with a gas burner that it's hard to see, but it's, maybe you can see it. It's anyway, it burned for a while, and they ignited it with a short duration burner ignition, and then they let the mulch do its thing, and they measured that. This never did come, a standard test method never came out of this, but it's a way to think about how it might. So let's see. And this is some of the results. It really took the larger the chunk, the harder it was to ignite. And so they needed the Class A ember, so to speak. But, you're not going to see a Class A brand being lofted. It just won't happen. But you need a larger source to ignite via embers. And I think the thing that you don't see here is the difference between a mass flux, the total amount of embers coming, and the representative same number of, so a number flux, like 5,000 per minute versus 2 larger ones. What's the equivalency? Well, we don't have an equivalency for that. But I think that the finer the fuel, the drier the fuel in terms of mulch, the easier it will be to ignite. And so, you can get by with a large number of small things instead of a smaller number of large things. And then with the flame spread, you see, let's just look at the pine straw because it's the thing that's easiest to ignite, and you get a pretty rapid flame spread. And I just sort of rounded and converted for you. So somewhere between half a foot per minute and a foot per minute is sort of the rate at which that was moving. Again, we did some tests at IBHS, and the pine straw can move pretty quickly, and pine straw burning can move pretty quickly. The whole bottom line here is that I think it's easy to say that embers are going to ignite mulch, and that it'll burn to the building because you have fuel continuity. When you have a mulch bed, it can burn with convective and conductive kind of and radiative kind of movement to the building away from the building. It's going to burn it into unburned fuel if you give it enough time. So this is what we're going to be doing in West Marin. If you've driven out there, you may have seen these. It's sort of at the intersection of Sir Francis Drake Boulevard and Nicasio Valley Road. It's where it's right next to where the clubhouse was when this was a golf course. So we have 10 mulch types. The thing that I was interested in pursuing this particular new study is the observation in the Nevada study that indicated that composting seemed to have beneficial attributes when it came to how mulch burns. So we remember that composted product did not exhibit flaming combustion, it was smoldering. So we have, in this particular series of experiments, we have 10 mulch types. 5 of them are composted, 5 of them are not. And then as with many studies, you replicate the thing. And even though this isn't exactly a block design layout, I arbitrarily carved those 30 plots that you see in this picture into 10 groups, or 10 geographically similar areas, and then randomly allocated each mulch type to one of those 3 things. So we have one of each type of mulch in each block. And these are all 8-foot diameter plots. And when we laid them out, they were 3 inches deep. There's a metal ring around each of those plots, and that ring stands above the ground 3 inches. And so they just filled it to the top. So there's been some settlement. I'm sure we put these out in early June. And as I said, we're burning in the second week in October. And so we'll be measuring mulch depth to sort of figure out the settlement along those times. We're going to ignite them the same way. Some of a sample of each one of the mulch types was I took it over to Professor Gallner who's a UC Berkeley faculty member. This is the lab where Luca worked, I'm pretty sure. They have a little wind tunnel that you can see in this picture, and Professor Gallner agreed to do some ember ignition studies on these 10 mulch types. And so they were delivered also in June, and he has finished those experiments. I haven't seen the results yet, but we'll be able to talk about ember ignition potential and the field results of flame spread and flame height and whatnot via a drip torch kind of ignition scenario. So I'm looking forward to this. I think it'll be sort of informative to add to the potential for ember ignition of mulch types. I think that's always useful information. So we have done some preliminary testing of the mulch types, and this is one of those 2 things that we have. The things that are of interest to help explain combustibility. One of them is ash content. And so we made a contact with the help of Jana Valakovic, a colleague in Humboldt County, with Professor Marshall at Humboldt State, Cal Poly Humboldt, to use her lab, and then someone that Jana has employed to actually do the grunt work, so to speak, and ash these 10 samples. And so this is an average of a few tests, but you'll see that there is clearly differences in ash content from the composted ones to the non-composted ones. So we'll be able to talk about that as a function of combustibility results. That once we do that. And then also the other thing that I was interested in was the relative material size or particle size within a mulch type. And that red arrow at the bottom there on number 8 is just letting you know that the larger pan, so the 1-inch grid, there's only one mulch type that had that size. All the other mulch types had things smaller than, but not bigger than. And so you're going to see 4 bars in each one except 5 bars in the number 8 one. We use this particle classification apparatus, the ROTAP picture on the far right here. You put a fixed amount in the top and you shake it, and then if it flows through to the next one, it flows through, and if it can't, it stops there, and you weigh each pan, each each sieve type at the end of shaking, and then you can, we started with 100 grams, and so it's really easy to translate it into percentage. And you'll notice that there's a lot of fine fuels in most of the mulch types. That should make it easier to ignite, and then the larger chunks would burn longer. So I think knowing the ash content and this relative quantity and the moisture content that we're going to get on the day of the test should help us better explain some of the factors that influence the combustibility of mulch types. So I'm interested in seeing what's going to happen, and hopefully you are too. And just in case you've never seen this, we visited the West Marin compost. That was pretty cool, and I think, and the picture on the right is this gizmo that turns the mulch, and then you end up with the left-hand picture, which is the rows of composted composting material. I think the reason why compost has a lot of ash in it is because of this turning in most compost and mulch types. So you get some dirt in there, which accounts for the fines, I think, or the small particle size, but also the ash content, elevated ash content. And I just wanted to give a shout out to the large number of contributors to this particular study. It's just amazing to me that we had so much cooperation from so many people. So as I indicated, Professor Gallner and his postdocs and grad students at UC Berkeley. We had the help of Dan Jimenez at the Missoula Fire Lab, who is donating some fancy equipment for us to measure radiant heat and temperature from the burning mulch bed. Professor Marshall, that opened up her lab to let us use her equipment, the ashing, the muffle furnace, and the particle classification system, the shaker thing that she has. Then Jana and Wallace at UC Humboldt. This whole thing is being funded by the Wildfire Prevention Authority, MWPA. Thank you, Marin County taxpayers. Fire Safe Marin has been very supportive along the way, and they're providing a videographer guy that's going to come and help us document and measure and video record some of the tests so that we can do some post-processing of flame height and flame length. Scott Sherman and his Avid Green people, they set out the mulch beds. They've been really cooperative. Todd Lando, my colleague at Central Marin Fire, sort of made this happen, I think. And then we had some help from a consultant back east, Ron Alexander, in finding some different kinds of sources out here. Sophia and Stephen, helped us narrow down the types of mulch we're going to use. And then my colleague, Dan Gorham, who greased the skids with Dan Jimenez to get the equipment here. So anyway, a lot of help along the way, and I really appreciate that. And that's all I have. So I think you have my contact information, and I'm going to stop sharing and let Sophia take it away.
Thank you, Steve. Really appreciate your presentation. And we have a lot of questions in the queue really pertaining to mulches. But before we get to the Q&A, Mimi and Yvonne are going to be helping with that as well. But Tori had some clarification on her presentation, so I was going to let her start with that and maybe update us on some information that, okay, there we go. And Tori, you're still muted. There you go.
Yeah, just realized that. Steve Quarles just kind of called me out on something real fast. And I want to point out that Zone 0, the language that they're talking about right now, even though it's stalled, is not about parallel fencing, it's about perpendicular fencing. Thank you, Steve, for catching me on that one. Just further clarification, Zone 1 doesn't really address any of this legislation wise. It doesn't address lawns. It doesn't address like spacing issues. Like I said before, this is why zone 0 language is going to be a little bit more bulky if it gets going again. So they will address this based on my contacts. So that was my clarification. Sorry for giving wrong information.
Well, I'm glad we caught it. Okay.
Can you reshare that? So isn't a perpendicular fence just a fence or a gate that attaches to a house?
Yes.
Yes.
So it's kind of a repetitive of the bullet you had above it then. Right? Just want to clarify.
Yes.
Great. Got it.
Yeah. So like it directly feeds into this gate or fence that attaches to the building. It kind of feeds into that.
Perfect. Thank you.
Yep.
Okay. Thank you very much. And as I said, Mimi and Yvonne or anyone else, if I accidentally skip over a question or something, just please bring it back up. We had one way at the beginning from Stephen Swain's presentation talking about the Oakland house. And it said creating fire-wise zone seems to be completely contradictory to why the house in Oakland survived. I am completely confused. Hopefully after the 4 presentations, you got some clarity, but it seems that the rule is really about focusing on fire hardening the structure itself and the roof. And I don't know if Steve or any of the other ones want to address that. I think there was some clarification in talking about fire's approach to the house and vegetation, etc. And
yeah, there are a lot of microclimates that can occur during a wildfire, and it's hard to know exactly what all went on. It did seem to have a lot of vegetation around the house. It could have had certain home hardening features that helped, but it is also possible that they just didn't have the ember exposure that other houses had. And without being there, it's kind of hard to figure out exactly what went on, except that it's sort of a too commonly used phrase, but you have to meet certain criteria for combustion, and if they're not met, that doesn't happen. And so they just weren't present there for whatever reason.
Okay.
My point was simply that it's number one, it's about the house, and so that was the point that you're sort of saying so you got the point. It's mostly about the house. Vegetation does matter, but you can get away with not following all those rules, and it's still possible. That's what I was trying to say. It's 90% of it. It's just the house, right? The ember ignition issue. So you got that one. And there are other factors. And as Steve Quarles already said, it's hard to say why exactly that house survived. I've heard some people, firefighters, posit that those trees around the house may have actually shielded the house from some radiant exposure and actually contributed to the house's survival. The point here is really that you have to take care of the house first. Landscaping is secondary. That's all.
Yeah. Trees can be radiant barriers, but they are until they're not.
Right. And then they actually burn, right?
Okay. I was going to say next in there was not a question, but just something promoting fire-wise neighborhoods and contacting fire safe in your community, and really want to promote that community efforts into implementing some of the stuff that we had learned about today. And just want to give a shout out to that person and that had mentioned that in the Q&A. And then what do we have here? Would one of the panelists speak to the health of the soil that has been covered with rock mulch?
Is that going to fall on mine? Probably.
Okay.
So the whole soil is fed by mulch, and particularly fed well by composted mulch. So in the area 5 feet from your house, you may be, if you're in a fire-prone area, you're probably more concerned with your house burning down than the health of the soil right within that last 5 feet. If you're you can use mulches away from the house, and that's still acceptable. You saw Steve Quarles put up a number of pictures of mulch beds that burned. They were away from the house. It wasn't a problem. It didn't set the house on fire. So you do want you want an organic mulch to feed your soils, but closer to the house, the point of the firefighters here is that the safety of your house probably trumps concerns about soil health right against the house. You're probably not wanting to grow very much there anyway. Now, if you are super concerned about the soil health, then you can put mulch down in those areas close to the house. But you're probably best advised to do that in October. That will break down during the rainy season. And if you put a small amount of mulch down, then you will have less than an inch. If you say put 2 inches down in October, then typically you'll have an inch or less by the time the end of the spring rolls around, in which case you've got very little mulch to carry anything. Does that mean you're at higher risk for fire? Absolutely it does. Anytime you have anything flammable within 0 to 5 feet, and if you decide to take that chance, I mean, I guess that's kind of on you. There are ways to put in things like succulents that don't particularly care about having high organic matters, or things like that might be acceptable. You could grow plants that don't need a lot of organic matter, probably don't need much in the way of feeding soils to help you. And I'm talking too much, but I hope I answered your question.
Okay. I think so. And I think, where did the rock mulch? And then we had a question regarding Luca's presentation. How were the plants irrigated, overhead drip, other? Are there any planned studies to investigate the impact of different irrigation methods? And it said, FYI, some consultants in SoCal dismissed drip irrigation, while NorCal drip is generally the recommended irrigation method.
Yeah. So
Luca.
I heard about this different approach, like this different regional approach about drip irrigation or not. I'm not an expert of irrigation, so I'm not sure why some people do not want to have it. I heard that like drip irrigation sometimes attracts ants and might damage the root system of a plant, but I don't think there's any study that proves that yet. So I don't want to like speak on terms of those, but the plants that I burned last year are subject to drip irrigation, and also the ones of this year are exposed to drip irrigation. That's like the standard method for the plantscape irrigation trial study.
Okay, thank you.
Do you want me to talk about irrigation?
I don't know.
I don't know either. We do have.
Also, I will say we have a lot of questions.
Yeah.
We're either going to run late, and if folks are okay with running a few minutes late, we might. There's a whole series at the tail end of the Q&A around mulch, and I think people are really, really interested in diving into that. So if we're okay with going a little bit late, I think maybe we ought to focus on the question list rather than maybe expounding on the irrigation topic.
Okay. I agree. So I'm happy to tackle mulch if you want to stay after, or somebody wants to. Okay. But let's talk about all the mulch and fire stuff.
And then there was a question about artificial turf. Does it become more flammable over time? Do we know the answer to that question?
I've done some studies on artificial turf, and but not the aging one. But I don't think the aging would have too much of an issue here. The artificial turf that we evaluated, again, when I was at IBHS, it had a propensity to smolder. It didn't really start flaming unless you had vegetative debris around it that ignited also. So when flames touched it, it would definitely flame. But with strictly an ember exposure to the artificial turf, it was smoldering. So I'm not quite sure that helps with your answer, but and definitely doesn't address the weathering part. But plastic lasts a long time, so I think in the lifespan of a house, it would act about the same. You want to do your best not to let vegetative debris accumulate a lot on it, because when it ignites, then the turf will help contribute.
Okay, And does it become more flammable over time? There's after the turf one, is there any treatment you could apply to wood siding to retard combustion?
No.
You gotta love a direct, terse answer of that nature.
So just not to turn into Stephen Swain, but there's a polite joke. We are finishing a study now, and it should be out, probably early 2024, where the studies on these coatings, and I think we need to talk about this in terms of the paint coating as opposed to a gel, which is strictly temporary. Paint coatings, the studies that have been done had the fire retardant coating as a top coat. And we're finishing a study now where the fire retardant coating is like a primer, and there's a regular old exterior paint top coat on it. And we've weathered it. Some outside that weathering happened in Marin County, the natural weathering, and then we did some accelerated weathering at a lab at the Forest Products Lab in Madison, Wisconsin. And the fire testing was done there. And so we are now working on the report. Anyway, the question is whether, if you have a top coat applied to the fire retardant coating, whether that will enhance the effective service life. And I don't know the answer to that yet, but it's possible that application and the order in which you apply the fire retardant coating may allow for a longer service life. We'll see. But for now, I think the answer is pretty much a no.
Okay.
Sophia, you skipped one on the sheet mulching. Somebody asked about sheet mulching.
Yeah, but there's someone who actually did a little more detail on that a little later.
Oh, okay.
Yeah,
great.
I think we're going to get back to it.
Okay. We say the next one regarding mulch again. Other than the non-combustible, is there a recommended mulch depth, maximum or range that would address the following concern? The concern of firefighters is that deep mulch could smolder, not be noticed, and ignite after a fire crew leaves the property.
That's true for mulch and other things. The Carson City study that Ed Smith and I did pretty clearly showed that less mulch is better. So we had that single layer Tahoe chip and then a 2 to 3 inch layer of Tahoe chip as an example. And the single layer was less of a hazard than the thicker layer. So I think it's quite possible. I think that other thing that maybe Stephen Swain could talk about, though, I've observed, and maybe you know this better than me, but if you have a thick bed of mulch, then it's sort of wet down there. At some depth, it becomes wet, and so harder to burn. And so you have, it's sort of a function of moisture content as a function of depth.
And if I can quick follow up on the smoldering. So I actually worked a lot on smoldering of woody fuels in the Berkeley lab in like the wind tunnel that Steve showed. And so you don't actually need a lot of depth for having smoldering. Like 1 or even like 2 inches might be enough to like hide the smoldering going on at the bottom. And then eventually there's like a puff of wind or something and you get transition to flaming again. So you don't need a very deep layer to have smoldering.
Thanks.
Okay. Next question. How does arbor mulch chipped material that is not composted?
Well, maybe it might be helpful, Steve. There was questions about, so what is composted mulch? So maybe if you could talk about what the process was for the composting of the mulch, that might help with some context for that question.
So I only know composting. I think Stephen Swain should talk about this one, because the composting that we took the word that it was composted, and it sits out there and gets turned. And so you have a lot of heat degradation occurring. but I think the advantage of composting isn't so much the compost itself, it's the dirt that sort of gets mixed in. But in terms of the actual process, I think our Stephen is a better answer.
So composting is a process and mulch is a substance, right? So composted mulch is just, you're using compost as a mulch. And compost can be made of a variety of different things, but ultimately it's vegetative material that has been broken down through the composting process, and the composting process is legally defined. And we can talk about what those are at some point. But again, it gets very technical very quickly. And I think it's kind of beside the point here for talking about fire, the differences between different composting methodologies and what makes it compost and what doesn't. Suffice it to say that a lot of things, for instance, when I was working in the tree industry, if you put a bunch of chipped tree in the back of a truck in November, you'd come back out the next morning if you hadn't dumped it yet, and that stuff would be steaming because it would have already started composting in the back of the truck, just being there. So now that's not legally compost because it hasn't gone, nobody's checking the time and temperature, and composting is a legally defined process where you have to go out and check the temperature every day, yada, yada, yada. But a tree guy could honestly say, well, it started the process anyway. So exactly when does it become compost? Again, depending upon the thing, it can be several days, it can take up to 2 weeks. But it is, since it's legally defined, all you're saying is I'm using compost material that's been composted and I'm applying it as a mulch. So that's composted mulch. Does that make sense, or did I not explain it very well?
Well, so I feel like we could, for master gardeners, because of the study, the original study with University of Nevada at Reno that Stephen Quarles was involved in, that talked about, one of the materials was a composted wood mulch that had some defined process for how they created that, and what process that underwent. Whether that's fits with the definition of composting legally is, I don't know. But then, for example, Stephen also had a picture in his presentation that showed Marin composting operation, and it looked like wood chips that they were turning and doing some type of composting process. So I feel like that would be a really valuable follow-up question maybe for us to pursue, for understanding when people are using that terminology. It may not be formally following the legally defined composting process.
It has to. If they're calling it compost, it is defined as.
So whether or not that's in fact true, I think we need to do some follow-up to dig into when people are using that phrase, with what exactly that means. Does that mean someone's aged it for 2 weeks, or what does that mean? I think that would be an important follow-up aspect for us to dive into.
Okay, so do you want me to talk about the composting process?
I don't know that we have the time today to go into that, especially given the depth of questions we have, but I do think it's worth us trying to follow up and pursue as a topic, as a group, for having a better understanding of that.
I agree.
And that kind of touched on a few different questions. Mimi, if you'll help me kind of navigate which one maybe we should go to next.
Well, so I think it would be helpful to talk about sheet mulching, because it is a process that we recommend as master gardeners a lot. And the question is, so how does that contribute to possible, higher fire risk? And the question is, because you're using this layering, of cardboard and wood mulch and sometimes compost, should that be limited to zone 3 and avoided in zone 1 or 2? Anybody have any thoughts on sheet mulching and whether that increases your flammability risk in closer zones to the house?
So I thought that sheet mulching, one purpose, I don't know all the purposes, but is it to minimize weed growth up through? And so to the extent, if the top layer is a wood mulch product, then I don't think it's going to, a wood-based mulch product, then composted product, I don't think it's going to matter one way or the other.
I don't think we have a lot of data.
If the top layer is a rock mulch, then, why wouldn't it help?
I would also think that you usually use the layer mulching in areas where you're trying to replant something. So I would say typically you're not going to use that right up against your house. I wouldn't think. So it might be in a zone further out, you know, so it would be reasonable that it would be a 3 foot out or 5 foot out area.
Sheet mulching's lousy for your existing plants. So like Yvonne said, you probably don't want to do that around existing plants. So most often it's using vegetable beds to wipe out Bermuda grass and stuff like that. Not really appropriate for a lot of the things we're talking about here, but it doesn't mean somebody couldn't do it.
Well, replacing lawn is where we see it most often.
Right.
Right. So that could be up against your house, I suppose, if you had lawn right up to your house.
Mhm.
Okay, I think that probably covers the mulch questions. Should we shift on to a few others?
Yes.
So there's a question from Jim Casper about, is there any work or even an informal study or report regarding plant suggestions for hedges or privacy screens? I guess that's one of the most frequently asked questions that they get. Anybody aware of anything in that regard?
Happy to opine that hedges are lousy. They're by definition horizontal conduits for fire. Pretty much they're sheared, so they tend to have really fine fuels in them. The idea that you're going to have a fire safe hedge it's a slightly contradictory in some ways, but I'm interested to hear other people's opinions on that one.
I agree with Stephen.
Sounds like we don't have any other input on that. Can someone define ash? What's the definition for ash?
Inorganic material.
So ash, so when you and Luca were talking about ash in the studies that you were doing, you define that as inorganic material. So it's organic material that's been
No, it's inorganic.
Yeah, usually it's like all the minerals and they're
Yeah.
left over by the things that don't burn and like are left over by the combustion process.
Yeah, as opposed to carbon-based something.
Okay, perfect. Okay, I think we're honing in on a few last questions. Could someone, Tori, provide more specific information regarding what will be in the CAL FIRE Zone 0 regulation? And also when that, well, I kind of feel like you kind of covered that, Tori, that might have predated. So the let's just be clear. It was legislation passed by the state of California. It then went to be defined how that would be implemented. And that
language was
the language for how that's going to be implemented, what's the requirement is going to be that's going to be communicated. But that's what's being debated. So did I say that fairly, Tori? Okay. And that's where Tori's suggesting if you can promote to your local legislators the importance of Zone 0 and for pursuing and getting that legislation language completed. That I think that was the suggestion.
So the language has been developed. There was a committee that the Board of Forestry and Fire Protection established, and it became a broader committee. That committee came up with language that was agreeable to the committee. And then it had to go to the governor's office for economic evaluation. What would this do? What's the economic impact? And so it went to that kind of review. And then I think politics stepped in, and now it is where it is. But there was agreement within the committee in terms of the language. And the language, that draft language is sort of out there.
Okay, so I think 2 more questions and I think we might get a wrap. Is there any talk or consideration in house hardening concerning the bottom 2 feet of a home with some type of masonry material?
So I think Luca and I can address this, but we've been talking today mostly about horizontal surfaces. So right next to your house is Zone 0. That needs to be, in order to have a home that can survive wildfire, you need to be as aware of the vertical surfaces near horizontal surfaces. So this could be ground to wall, deck to wall, roof to wall. You need this non-combustible zone vertically also. Wind blowing, as you know, in Tori's presentation, she talked a lot about wind blowing against the building, some of the experiments. The accumulation zones there's a couple, but the one that is really important right now is that embers will accumulate at these horizontal to vertical intersections. And so if you have a combustible thing coming right down to the horizontal surface, even if the horizontal surface is non-combustible, if that thing touching that horizontal surface is combustible, then those embers that accumulate right at that intersection will ignite that combustible thing. And so you need to combine the horizontal non-combustible surface with a vertical non-combustible surface. And it doesn't need to be as tall as, you know, as large as a horizontal one, as long as there's nothing combustible in the horizontal one. But the more you have combustibles in the horizontal one, the larger, the taller the vertical one needs to be. So I think that's the thing. It's hard to say that the vertical one needs to be X unless you know about the horizontal one.
Super helpful. I think the wrap question, and maybe we just round robin with the presenters. Most home gardeners want some simple suggestions that they can implement. If you're talking to someone at a farmer's market, rapid fire, what would you suggest is the one thing to do? You want to lead us off, Steve?
Horizontal and vertical non-combustible zones are really important for homes to resist ember ignitions.
Luca?
Yeah, sorry. Definitely, yeah, start from the structure and trying to work like on that zone zero. Like, yeah, the first, I guess that's how I will prioritize it.
All right.
Going off of that, chunk it out. You don't have to do everything at once. Just find out your biggest priority and work from there. And it's going to be a project.
And Steven?
Start with your house, the vents, all that other stuff. Then worry about the garden.
And if you're in a high fire severity zone, implement your zone zero. All right, Sophia.
Okay, everyone, thank you. Our panelists and Mimi and Yvonne for your assistance as well. And thank you all for attending. This has been recorded. As soon as I get that straightened away, we will forward those to you. And I will capture the remaining questions and have our panelists take a poke at them and then forward them to you as well. Thank you all for coming here today and enjoy your afternoon.
Thanks very much.
Thank you all.
Let's try and end recording. Stop recording.